Well, it is now 9:30 Central Time in the United States on September 23rd, and this is the MyGuru to plug in or not plug in quantitative review information session webinar. I'm going to just pause the recording and wait for a couple of minutes while we allow more folks time to arrive. It is now 9:35 Central Time. I think in the chat box I put Eastern Time for both 9:35 and 10:35. But we'll go ahead and get started on our discussion of the quantitative comparison content. Now, just to the right, you can see a copy of the quantitative reasoning section from the official GRE textbook. Now, you can see the topics that are included: arithmetic, algebra, geometry, data analysis. Covers basics up to like early to mid high school math here in the United States. Nothing beyond plane and coordinate geometry basics. You won't need any trigonometry. You won't need anything really all that far into algebra 2 even, and certainly no calculus. So there are different question types within the quantitative reasoning section. And the one that we're going to focus on today is this guy here, the quantitative comparison questions. And no matter what happens with your exam, you're always going to begin the section with the quantitative comparisons. It's just how the test is organized. So just from a kind of definitional standpoint here, so text box here. So we know quantitative comparison overview. So they are always the first, generally 7 to 10 questions. Technically, it can go either way, but usually 8 or 9 in a computer delivered GRE. Now, we're going to assume everything's computer delivered. It is a little bit different, as it says, for the paper delivered test. It's exceedingly unlikely that you're going to encounter the paper delivered exam. So we're just going to assume that it's computer delivered. And so they always start your quantitative section. You're going to be looking at 4 static option choices for every problem. And so these choices, and we'll talk about them in detail as we work through a couple of samples in a moment, are as follows. So A means that quantity A is always, or well, let me just put it like this: quantity A is greater than quantity B, and you need to highlight always. So it has to be consistent. So quantity A is always greater than quantity B is our first up here. Yep. Then choice B means that quantity B is greater than quantity A. And again, always. Then choice C is that quantity A is equal to quantity B, and always. And choice D is that there is no consistent relationship between the quantities. Quantity A and quantity B. So that's basically you're not always, right? Sometimes quantity A is greater, but sometimes quantity B is greater, or sometimes they're equal and sometimes they're not. So these are the basic choices. They will never change. So whenever you encounter a quantitative comparison question, there's your answer choices, basically. So you see A greater, B greater, quantities are equal. It cannot be determined. And you'll want to memorize these questions because it's just not beneficial to have to think about them every time. Now, for the quantitative comparisons, generally, what you want to do is limit yourself to an average of under a minute 30 per problem. And understanding that the average per problem for the quantitative section is going to be about a minute 45 per problem. So what that means is that the quantitative comparisons should go a bit more quickly than those problem solving questions, because there's just first fewer answer choices, and second, you could potentially do some logical estimation to avoid over calculating. There's often opportunities with the quantitative comparisons to save yourself quite a bit of time. So now you also, because they're the first 7 to 10 questions, you want to always aggressively attempt to at least logically eliminate choices for every quantitative comparison first in the section. So you really want to avoid kind of skipping over these, because they are just much easier problems in most cases compared to some of the harder problem solving questions. And you usually are going to be able to not only have it be a 1 out of 4 guessing opportunity, but frequently 1 out of 2, 1 out of 3. And we'll talk about why that is here in a moment. So let's go ahead, take a look to start at number 1. So let me see if I can't make this a little bit bigger, but not quite huge. So it is not where I want to go. Yeah, pretty much it seems. So yeah, perfect. Okay, so whenever you start with a quantitative comparison, you want to first set up the scratch pad. So we're going to have question 1 here. Quantity A is just going to be listed out as the least prime less than 24, and quantity B is the greatest prime less than 28. And I always like to just put our answer choices in the middle for process of elimination. And you can use some little helper symbols to shorthand what we just talked about in terms of the static choices, because we know that choice A means A is always greater, hence the greater than sign pointing at choice A. Always greater, hence the greater than symbol pointing at choice B, or sorry, quantity B. C means they're equals, hence the equal sign, and NA over D means that not always is the relationship the same. So it's just a nice little device that allows you to kind of set this up. So coming over here just a little bit, we're going to talk about how we want to work through this problem, and by extension, all quantitative comparisons ultimately. This is going to be our quantitative comparison process. A little bit over here. There we go. So step 1 is what we've already done. So set up the scratch pad. And so it's going to be either scratch pad of like a whiteboard. You'll have to provide your own if you're doing the at-home GRE, because of the year 2020 that is so strange. And right now, at least, you are able to take the GRE at home. I believe as of this message, it is available through October 31st. Of course, that is something that could change at any time. So do check the official ets.org/GRE website for updates on the availability of the at-home GRE. But for the at-home GRE, you're going to have to provide your own little whiteboard that's erasable, and your own little whiteboard markers. If you can see me in the corner, you have whiteboard markers over here to the left of me, and that allows you to prove to the proctor that you are erasing. Now, if you go in person, they'll provide you with somewhere between 2 to 6 sheets of scratch paper at a time, and you'll have pencils. So it's more standardized there, even though they can change the amount of sheets of scratch paper, but it's ultimately unlimited. You can always ask for more. But either way, you're going to write down everything for not only the quantitative comparisons, but just about every problem on the GRE, to make sure that you don't make mistakes. So you set up a scratch pad. You do so quantities first, as we just did, right? And you can articulate the information as mathematically as possible. You can list the choices in the center for process of elimination assistance, like we just did, and you can place any conditions for the problem above the quantities and above the choices. Now, in this case, you can see there are no conditions. It just is quantity A and quantity B. So we'll take a look at another one in a moment where there are conditions, but right now there's nothing. So then step 2 is quite simple. It's just to ask a single question. Do I want to plug in? And the default answer here, we want to be no. And if the answer is no, then you just want to evaluate as mathematical conditions and the quantities as mathematically as possible to determine if there's a consistent relationship or if a consistent relationship cannot be determined. Now, the real nice thing about this is that we can actually immediately eliminate choice D if there are no variables provided in the problem. So here, we've got the least prime number less than 24, and we've got the greatest prime number less than 28, right? Or sorry, I got this backwards. My least prime number is greater than 24. And this is why you always write things down, because you might catch something for yourself like that. So least prime number greater than 24, the greatest prime number less than 28. So what we want to think about here is, first, are there any unknown values? So going back up to the chat message, are there any unknown values or variables in this problem? So just to the group, are there any unknown values or variables in this problem? So no, obviously, right? I mean, there's definitely a one least prime number greater than 24 and one greatest prime number less than 28. So because of that, we can eliminate D immediately, even if we don't know what prime number means. If it's just something that's been forgotten over time, you can immediately go, well, there is a least prime number greater than 24, and there is just one greatest prime number less than 28. So it can't be D. So that's what we're going to do to start here. Now, then we want to just consider this least prime number greater than 24. So what makes a prime number prime? Pardon me. That's right. It's going to be a number that is divisible by only one in itself. So we can just try to work through quantity A here by thinking, are the integers, and it's only integers, that are greater than 24, are they prime? So is 25 going to be prime? No, right? Because it's divisible by 5. So how about 26? Well, no, right? Because it's an even. Yeah. How about 27? Well, you got to be careful because 27, for instance, there's a rule for seeing if it's divisible by 3, which is if you add 2 to 7, then you get the sum of 9. And if the sum of the digits of any integer is divisible by 3, the entire number is divisible by 3. So 27 is out as well because it's divisible by 3. Now, 28 is an even number. So we know that that's not prime. And then 29, well, there's our prime number. So that's the least prime value greater than 24. Now let's think about this strategically. Do we even need to test quantity B? Why not? So yes, we know that quantity B has to be less than 28. So B basically has to be less than 28. And we already know that 28 is less than 29. So you want to avoid unnecessary steps as far as maximizing efficiencies, because I don't need to actually work through this in its entirety. I don't need to figure out what the greatest prime number is less than 28, because I know it's going to be less than 28, and I know that 29 is already greater than 28. So quantity A is greater, and we select choice A. Any questions about this first quantitative comparison example? So then we talked about this asking, do we want to plug in? So if no, we've got the approach right there. Now, sometimes the answer is yes. And if the answer is yes, you want to first plug in an easy value or values, depending on how the problem is set up, to determine one possible outcome for the quantities, to eliminate two of A, B, or C. Because this again gets us to that idea of I can just logically eliminate things pretty quickly. Even if I'm not 100% certain, I can basically get it down to either one of A, B, or C. Because if I plug in, I model one situation, you go, oh, well, if then I know that B is not always greater, and I know they're not always equal. So I can eliminate those. I'm basically left with whatever was my first outcome and D. So let's continue down here a little bit, and we've got another example. So again, we don't care about the answer choices because we know what they are at this point, but I'm going to just set up this second problem, number 2. And so we've got quantity A, number 2. Here. So quantity A, we've got twice Lionel's age. And like I said, we want to mathematically articulate information as much as possible. So I'm just going to say 2L. And then quantity B is going to be Maria's age. So that's just going to be M for me. So we've got A, B, C, D here in the middle. And again, we can use those reminder markings if we like. And now we do have a situation where we're told that L is less than M, because Lionel is younger than Maria according to the problem now. So now we've got a situation where, so coming back just to process over here. So easy values are generally going to be 2, 10, 100, or 1/2. And just stuff that makes the math simple. So picking from this list, well, I could have a situation where L is equal to 5 and M is equal to 10, just picking two of the numbers that are in that list. So if this is the case, we know that 2 times L in this first scenario would be equal to 10. And then we've got M itself is equal to 10. So now we can eliminate answer choices A and B, because we know that A isn't always greater and B isn't always greater, because right now they are equal. But is this the only possible outcome? Of course not, right? It doesn't say that Lionel and Maria have to be exactly 10 and 5. We can just change things up. So once you've worked through that, so you first plug in that easy value to determine one possible outcome. Then you want to test. So, and basically, let's just kind of make it a third step. So, because it gets a little bit more complex, but this is for plugging in only, which is going to be to retest additional values to determine if the original outcome is the only possible outcome. So, and there's going to be a using the frozen checklist. So we'll talk about what the frozen checklist is in a moment, but ultimately, and you want, and I should put the word strategically here, because you don't want to necessarily just go in the like not alphabetical, but the acronymical, whatever. You don't ROZEN. You want to think about it more strategically than that. But ultimately, as soon as a different outcome is produced with another plugin, you will just select D. So as soon as you get something else, if you're like, well, the first time it was equals, but the next time it's something not equal, I immediately select D. So that is really the goal of plugging in, is try to get to changing the outcome. Then if a second equivalent is produced, meaning basically you've got C twice with another plugin, then you'll select C. So what that means is, because the quantities being equal is so specific of an outcome, you can just say, okay, if I produce this, probably always going to be equal. There's a little bit of a catch here. You may have to be, again, very strategic in making sure that you're not like picking 1 and then 0, because they'll both do some pretty strange stuff with the arithmetic. But generally, if you pick an easy value like 5 and 10, and then you try it with another and you get the exact same outcome, it's pretty good that it's always going to be equal. Now, you must test at least 2 allowed frozen values before selecting either A or B. So if you get quantity A is greater, once you've got to test 2 frozen things to make sure that it doesn't happen again. Excuse me. So let's come over to the other side, and we're going to list out just our frozen checklist for quantitative comparison plugging in. So our quantitative comparison plugin checklist. So, thanks to the good people at Disney, got a pretty memorable mnemonic here. What just happened there? Let's come back. What's happening with my There we go. So it's just going to be FROZEN. And so first is the kind of number that is a non-integer that does strange things to math. That's a fraction. Because obviously they can have a bunch of different outcomes. Now, in this particular problem involving ages of Lionel and Maria, I'm not really worried about fractions, because it's unlikely in real life that they're going to be talking about fractional ages. Yes, you're like very young toddler niece, the parents may be saying, she's 2 1/8 year old, but that's probably not how the GRE is going to structure it. So not really relevant to this problem, but certainly relevant to others, is to think about, could we use a non-integer or a fraction? Now, repeats is going to be the same number for multiple variables, or a number in the problem directly. So here, what that means is I'm probably just going to keep one of the variables, and then I'm just going to change one of them. So there's just ways that you can repeat the same number, or use numbers like in quantity A, say it has twice Lionel's age. You're like, well, okay, so that twice makes me think that if I go with 5 and I use exactly 2 times 5, they might end up being equal, as they did. But that's the thing here, is you're thinking about how you could strategically use values in the problem or in the quantities or just the same variable, same value for multiple things. Now, I already mentioned these next two individual values, which are 1 and 0, because they do all sorts of weird stuff. So you want to consider ones and zeros as ways to basically create unique outcomes. E is going to be for the word extremes. And when you consider extremes, that would be in terms of range, right? So for range type concepts, it's something like if we were talking about 2-digit positive integers, for instance, I'd want to test a 10 and then I'd want to test a 99 because I know that anything in between that range is going to be between the outcomes for 10 and 99, just because one is the high end, one is the low end. And then N, of course, is going to be for those are our quantitative comparison, like conceptual numbers that we want to plug in if we're trying to disprove one outcome. Any questions about the frozen checklist? So then let's come back over here to our problem. So we've done L is 5, M is 10. Let's change it up. And we can do almost like two concepts simultaneously. So we're going to keep M at 10, but now let's make L just 1. So if L is 1 and M is 10, well, quantity A is now 2. And quantity B is, of course, still 10. Longer equal. This time quantity B is greater, which means that we can eliminate choice C and we would select choice D. So another thing that you can always do is kind of a speedy approach for the quantitative comparisons is consider, could they be equal, meaning the quantities? And also not equal, because if the answer is yes, then you just select D immediately. Because if they can be equal but don't have to be equal, we know that we are looking at a situation that cannot be determined. So those are basically all approach for the quantitative comparisons. Decent little overview here using direct content from the official guide. Very likely kind of problems that you'll see on the exam. Any questions about the quantitative comparison approach overall? All right, then. Well, if there are any questions in the future, feel free to email me directly at smainier@myguruedge.com. But otherwise, thank you for attending or watching if you're watching this after the fact. And I wish you all the best as you continue your GRE journeys. Have a great day, everyone.